There are two things that regulates our energy metabolism: the calorie in, the calorie out. But that's all just the concept. How exactly our body regulates those are through several mechanisms. And in this mechanism, brain plays an important role, of course, the mastermind of human body. However, there are systems that associated or working with the brain in order to balance energy in and energy out. And those systems involve several tissues or organs. First of all, we're going to talk about intestine or gastrointestinal systems. Our intestine has a role in regulating energy intake. They not only a place where our food is broken down and chopped and changes into smaller pieces and then absorbed. No, they also have a role in regulating our appetite. Another tissue is adipose tissue. Yes, the organ or the tissue that has a function to store energy can also influence how we eat, be able to influence the energy in and energy out. First, let's talk about the gastrointestinal system. In our gastrointestinal system, it's composed by our mouth, our stomach, and our small and large intestine, and several other organs that work around this, has a role in regulating our appetite. In our stomach, we can produce a protein called ghrelin. Ghrelin is a signal that tells our brain that our body needs more food. Ghrelin is produced by stomach, and it can be produced even more when there is a lack of food coming in to the stomach. It's like a bell or alarm stating that, okay, this is eating time, you are hungry, you need to eat more. Interestingly, the signals that ghrelin can induce works differently or work antagonistically with the signals released from intestine. The intestine has the ability to produce signals. Those signals are glucagon-like peptide or GLP-1, peptide YY, and also they can produce cholecystokinin. Those three signals release when we eat. When we eat carbs, for instance, our intestine can produce GLP-1 and or PYY. When we eat protein and fat, the intestine can release or produce cholecystokinin. Those three signals goes to the brain and tell us that we are satisfied, or we are no longer starving, or we are full, kind of. The signal is very important. Those two mechanisms, that protein released by stomach is a way of our body telling our brain that we are hungry, and then the other signals releasing from the intestine telling our brain that we are full, are those two mechanisms that help us to feel hungry and to feel full in certain moment of time. For instance, let's say today is 12 o'clock. It's almost lunchtime. The last time I ate was 8 a.m., meaning it already passed around 4 hours. And that last 4 hours, there's nothing getting inside my stomach. So what my stomach do? It releases ghrelin. Ghrelin signals then go to the brain and tell me that I'm hungry, I need to eat. And then after that, I go and have lunch somewhere. And a few minutes after eating lunch, all the foods has been chopped by my mouth, have been digested and going around my stomach and goes to the intestine. In the intestine, the foods then, the component that is broken down by the digestion system, and then makes my intestine release those peptides, the PYY, the GLP-1, and the cholecystokinin. Those signals goes to the brain and telling me that I'm full, I'm satisfied, I'm no longer hungry. And those two mechanisms is very important concept that drive people eat. Otherwise, I'm going to work all day without even think about eating. I mean, perhaps there's also something happens to you or some people, they forget to eat because there is something going on with the signals, or you are too distracted. You decided to ignore all the signals released by our body or your body. Those are signals released by intestine. The idea is to control what we eat and control the time that we eat and telling us that we need to eat. And interestingly, those are not the only system that regulates how we eat and when we need to eat. The other systems also releasing is the adipose tissue. The adipose tissue is active tissue. It has a very significant role in releasing certain proteins, important proteins, such as leptin. It releases adiponectin and several other signals that is still being investigated. And when we talk about the leptin, this very specific signal released by our adipose tissue, that leptin has the ability to control our appetite. When we eat more calorie, usually in the long term, we eat more calorie a day, let's say 100 to 200 extra calorie that we need every day turn into fat, and the fat after a month from gram into kilos additionally, and then the adipose tissue fat, like we are getting bigger. And in that moment, adipose tissue release a protein. The protein is called leptin. Leptin that is released by adipose tissue has two functions, or maybe there is some other function, but in the context of energy, there are two functions of leptin. The first function is to regulate appetite. The main function in this context is that when the tissue is being enlarged because they contain more fat, because we eat more, and then they release leptin, they're increasing the leptin productions, and that leptin will tell our brain that you cannot eat that much again. I mean, you have to reduce what you eat because our storage is getting bigger. And when that happens, we suddenly not very eager to eat, or our appetite actually reduced. And interestingly, leptin not only controlling what we eat, leptin also controlling energy metabolisms. What does that mean? It means that when the production of leptin is increasing, what it does also increasing the metabolic rate that we have. The amount of energy that our body use for energy, for activity, or for whatever things that we do is increasing because of leptin. So leptin has an important function in the context. It wants our body to stay the same. I think the idea that human being has a body, a system that has ability to control its own destiny is very interesting. When we eat a lot, our body tells the brain that we cannot eat a lot that much, we have to reduce the appetite, and also the leptin will increase metabolism. So then the excessive fat can be burned. We come back to the body weight that we were once, or when we started. So in this regard, that's the normal system that happens in our body. We have two different regulation of appetite. Those regulation by gastrointestinal system and those regulated by the adipose tissue. And those are important. What happens when people are becoming overweight and obesity? Those systems are not working very well. The signals somehow blunted or not being too sensitive to induce changes in body weight or to induce significant differences or variations. So there is a terminology called leptin resistance in the context of obesity. What does that mean? That when leptin is produced, the leptin signal is not very well received by the brain, meaning that although our body produces more leptin, the appetite is still high, and that will be a problem. And also, this system is one of the reasons why we have to actually take it slow when eating. You know why? Because as we eat, our body try to start sending the signals from gastrointestinal, from our intestine to the brain. And that takes time. So when we eat fast, sometimes we felt full a bit later, but we already eat too much. When we eat slower, piece by piece, then when we already felt full, we can just stop eating. And that's the reason why some people are overeat because they eat fast. When they eat fast, they don't give their body time to release signals, the signals to the brains telling that we actually already full. So, and that's a very basic concept on why we need to eat more slow. We need to enjoy what we eat and give the time to our body to communicate with each other, because this system is complex. This system takes time. That's two system that regulates our appetite. Thank you for watching the video until the end. If you are still interested to understand more about energy, appetite regulation in the context of weight loss program, please click the link at description. We have classes at Udemy for free just for you. See you.